you very much. Good morning, everyone. First, I have to apologize. I'm on Eastern Standard Time. So if I'm not as vivacious as I sometimes am, I appreciate your patience. I lead healthcare and life sciences for ConsenSys. So it's a great honor to be here today. I've been so looking forward to this workshop and this dialogue and what can come of it. And it was incredibly inspiring to hear everything that is going on in the European Union in this space. So thank you for that, and I'm really looking forward to collaboration. In addition to my role at ConsenSys, I wear a couple of other hats that helps inform a very broad point of view about healthcare and life sciences and this set of converging innovations. First, I'm involved with an organization called IEEE, which is one of the global standards development organizations. I chair a standard for blockchain in healthcare and life sciences, including specifically its intersection with other emerging standards, particularly artificial intelligence and the Internet of Medical Things. The activities of that standard are global. It is an open activity, and I'll be telling you more about it later. I also am the co-chair of the HIMSS Blockchain Task Force. It's the Health Information Management Systems Society. If you're not familiar, we're a very active working group with a global focus as well. And then I'm also chair of the Healthcare Special Interest Group at the Enterprise Ethereum Alliance. So lots of opportunity to collaborate. Before we jump in, I would like to reiterate what I've heard some of the previous speakers mention today, that it really is all about convergence. And whenever we're talking about blockchain in this space, we should not think of it in isolation at all. It is coming about and impacting our industry in the same way that, imagine that the Gutenberg printing press and the steam engine and the integrated circuit were all hitting commercial viability at the same moment in time, and we're all impacting a space equally massively revolutionary, relatively unpredictable in their impact. So as we're thinking about blockchain, we have to put it in context that this particular adoption curve, like you saw earlier, is not the only adoption curve that's happening. So as these technologies are coming together, one of the things that is important is looking at how they create benefits through force multiplying, and what kind of risks and barriers emerge because of the rate of change. So the other piece of context is that we really have had a global cultural tipping point with respect to the sense of the moral and just use of personal data. And no data is more personal and more intimate than our health data. There is a practice of anonymizing data, and when it is anonymized, it is removed from certain regulatory frameworks with respect to privacy protections. Unfortunately, those regulatory frameworks were developed at a time when anonymized data could not be relatively easily re-identified. Now,
here in America, I'm sorry, there was also a dedicated ongoing push to undermine privacy law in the United States starting 2001. I mean, it's not just accidental that this has happened. The impact of American companies who are designing to, for example, California state law and then exporting that, running over American HIPAA, running over the ADA, has been massive. It's not just accidental. Sorry.
Actually, I couldn't agree with you more. I don't believe it was accidental at all. There's a very strong set of economic incentives to monetize data. 25 years ago, the most valuable companies in the world by their market capitalization, not a single one of them had at the core of their business model monetizing data. Now they all do. The top 5 largest companies in the world are effectively data companies. I think that one of the reasons that thinking about unintended consequences now is so important, being ethically intentional now at the beginning of these adoption curves is so absolutely critical. I think one of the reasons we're all gathered here today is because all of us that maybe grew up through the dawn of the commercial internet recognize that we in our industry have left behind whole populations. Disparities in access and equity and outcomes are profound across the world. So we have an opportunity and we have an obligation. We have a responsibility to think differently now. So as we are seeking to guide and shape the way that these technologies will impact our industry. Just a quick follow-on comment around data. In addition to problems with data privacy and the ethical implications of data monetization, there's also been a lack of data access and liquidity, such that the original data subjects are among the least, they have the least access to their own data. Various laws around the world are seeking to mitigate that. One of them is in the United States that's created a new illegal term called data blocking, which for the first time now will be something where there's an investigation and enforcement provision to prevent healthcare delivery organizations from patients receiving easy and immediate digital access to their health information. So all of the use cases that we're going to talk about in my talk and through the rest of today have a certain set of common priorities that I believe we need to focus on. Each of these are unique to the healthcare industry, and I think of them as 5 priorities that should shape a lot of our discourse. And these priorities don't just apply to blockchain uniquely, but to the list of technologies and innovations that you see on the right-hand side of the screen. Blockchain is different from the notions of tokenization. We have this phrase we call privacy in depth, and my colleague, Dr. Pompak, will be giving you a lecture more in detail on that later today. But separately from blockchain, there are additional brand new emerging cryptographic methods that totally change the game of what's possible in terms of privacy protection paired with access. Usually there is a polarity of competing interests between privacy of data and the ability to access and utilize and compute upon data. Those are competing priorities. This new technology allows those polarities to come together. Decentralized AI is everything that you're accustomed to thinking about with artificial intelligence involves a presupposition that you need to move data from one place to another and assemble it in an ever-growing, enormous data lake. And that's a core premise. I believe that idea has reached its logical end in many scenarios, and we have new methods for machine learning that, when paired with blockchain, can radically accelerate the ability of a machine learning algorithm to learn and do so in a secure, privacy-preserving, ethically intentional manner. So our bioethics in our field have not had much of an upgrade since the 1970s. We live in an entirely different digital world, and it's time for us to rethink our bioethical frameworks for clinical research, for standard of care, even for the way that we frame and define health data. What is health data? Well, if my self-driving car is monitoring my heart rate, is that a medical device? And what does that mean for care, for example? It's a completely different paradigm than everything that we evolved to manage our earlier state. I've spoken a little bit about privacy, but we must have new ways to balance the interests of privacy and the sovereignty of the individual, as well as the ability to use and learn from and compute upon and act on health data in many contexts. Cybersecurity is an interesting one. You know, our industry globally in healthcare and life sciences didn't grow up being attacked by bad guys all the time. Unlike governments and banks, who were constantly used to criminal level or even nation state level negative actors seeking to break in, steal assets, etc., our industry has only been subject to that kind of threat for about really the last 10 years. Most of our corporate cultures in healthcare delivery and healthcare payments are oriented around compliance, which is important, but very much less so around cybersecurity. So meanwhile, we've got huge amounts of health data that are accelerating at an exponential pace. We have new medical devices coming online at an explosive rate. They're not even being discovered by networks or appropriately inventoried. There are massively increasing vulnerabilities and at the same time increasing attack frequency and severity. So cybersecurity in our industry is a top priority. What were you?
I'm sorry, I think it's been evolving. I obviously the R&D space, but I mean, you see, for example, in the United States, I'm sorry, I live here, but I'm going to use this as an example. HIPAA was a healthcare privacy law dealing with all of the database issues, all of the privacy issues, all of the transfer issues that were supposed to happen. That has never been properly implemented in the United States, just in the United States. And that is, I would say, as somebody who's fought for it, and been a girl geek out there doing that and saying things about, for example, Google, for example, and the running over social media. That until very recently has been tracked. So I'm delighted to hear that you're doing this, but I frankly have not seen corporate attachment to privacy in the United States, and I haven't seen it ever really been implemented. And that's a shame. And I hope that corporate partners like, for example, insurance companies start to wake up that they don't necessarily have access to things that they assume that they do. So.
Well, the HIPAA law you mentioned has a word portability in the name of the law that was never ever implemented in any way, and it's only in new laws and new regulations only currently coming into force, where we're starting to see the liquidity of data being mandated. You can't just keep it in a silo. You actually have to be able to let that data move and be computed upon and be utilized. So compliance, as we increasingly see cross-border and pan-jurisdictional requirements emerging, and levels of preemption up and down from federal to provincial and other layers of government, the ability to be able to mandate or enforce compliance in a way that is automated is a requirement. One of the things that brings all of our business and clinical and scientific processes screeching to a halt is because those compliance functions presently are very difficult to audit. They are impossibly burdensome to both the regulated and the regulators. And we have no efficient and immediate means to demonstrate that we've been compliant or to flag non-compliant actions. And so building that capability from the foundations into this next generation of technology is extremely important. And then identity. Identity I'm going to cover in more detail in a couple of minutes. We've got a lot of work going on conceptualizing what kind of identity requirements are unique to healthcare and life sciences, and I'm going to be telling you about that in a minute. But before we go into that, when we talk about blockchain as a term, I don't know how many of you are super familiar with blockchain, but it often ends up being obfuscated between many different technologies. So everything is built on top of today's modern web, but I think of these as 4 different layers that are being built on top. Each of them have implications from a policy perspective, from a governance perspective, who owns what, who's responsible for what. So we've got the actual blockchain networks themselves, which ostensibly you can say, well, the conversation ends there, but we know it doesn't at all. There are additional layers of how smart contracts are used, which aren't smart and aren't contracts, but I think of them as distributed, cryptographically verified stored procedures. But still, it's the ability to orchestrate processes across organizational boundaries instead of driving forever efficiency and automation inside of individual institutions. The ability to have tokenized assets is a completely new idea that opens up so much potential, and then our ability to put a user experience on a decentralized application that takes advantage of all these capabilities. But wait, there's more. This isn't the only part of this new picture. Some of this is old tech used in a new way, but it's also the first time we've had a chance as a society to apply game theory and run experiments to see behavioral economics and game theory applied in models where we can come up with an idea and say, well, we know we're in an industry that is characterized by wildly distorted incentives among the stakeholders. All these parties are pointing at one another as opposing forces. What if we could alter the incentives? Would it work? Well, in our industry, we should be posing that as a hypothesis. We should be using classical empirical models to study it. But we have a technology that would allow us to create a microcosmic implementation of a different set of incentives, and then let us run the experiment and see what works, and then model it and improve it on an ongoing basis. We've never had anything like that before. But we also have, we are going to hear a talk in detail about this family of technologies we call privacy in depth. These aren't blockchain. It's something else. It's something in addition to, that when combined with blockchain, equally impactful, equally significant, completely change the cybersecurity, the compliance, the privacy, and importantly, the bioethical posture of what it is that we're doing in our field. And then the notion that artificial intelligences can be developed, trained, and deployed outside of centralized infrastructures in decentralized models. This is, again, equally significantly game-changing. And blockchain infrastructures are the rails by which the value that is created through AI is delivered and secured. And there's a colleague of mine at ConsenSys is working very extensively in the bioethical framework. This is one publication of a half a dozen or so that look at the implications for blockchain, advanced privacy preserving technology, specifically on Belmont 2.0 and what we could do to rethink and reconsider what's possible. So I mentioned earlier I was going to talk about identity. I'm really passionate about this one. These are my ideas assembled out of working groups in the IEEE with colleagues around the industry about what's uniquely needed in our space in healthcare and life sciences for identity. So this is something that can potentially inform product development activities by companies around the world, and hopefully we will be creating a standard that in the next 18 months or so will be released and available. We would like to engage very broadly and globally on the development of that standard, and none is more significant than healthcare. So at IEEE, what we're planning to do is begin with an existing standard for identity, which is the Decentralized ID, or the DID. It's from a foundation called the Decentralized Identity Foundation. We think of that as just a starting point, just a beginning. The next thing that we need in a standard is to have a metadata framework that can be utilized globally that describes the context of that DID. So that would be, for example, how do you define whether someone is a patient, a research subject, a provider, an investigator? How do you use decentralized identities for things that aren't people, including devices, for example, places, locations, and so on. And then next, there's a thing called an NFT, which is a non-fungible token. And what that means is something like Bitcoin or ETH is fungible. One is the same as the next is the next. Non-fungible means that they're unique. And you might have heard of CryptoKitties. That's the most famous disastrous example. But this basic idea of something that is tokenized, that is a singleton, one unique thing, we believe is highly relevant to the notion of identity. And so instead of thinking of identities as singular, for example, I have one digital identity and it needs to control everything I do, from things that I do with my family, to my work life, to my financial life, to my medical life. That's dangerous. That's how humanity loses its freedom to global hegemony of governments and corporations. So just as information has been compartmentalized for decades, we have learned to secure and keep information compartmentalized. We need also to compartmentalize our identities. So what we need is a network of linked, non-fungible tokens that reflect personas or aspects of our identity. So I really don't want my employer to know anything about my marriage, and I don't want my bank to know anything about my health data, and I'm not interested in Amazon knowing anything about my health data either unless I choose to disclose it. So using advanced privacy in-depth tactics, we can protect and prevent the cross-referencing of these different identity personas. But at the end, how do you map any of it back to a physical body, a human in space? This is a major problem that we have if you were to just take the DID, the decentralized ID, and just throw it into healthcare. You could spawn up thousands of DIDs. How in the world could that possibly work in healthcare? Well, it won't. It won't. So another thing that we need in this standard is a model for creating a framework for multiple biometric attestations. So there's emerging new biometrics, everything from gait analysis to iris scans to you name it, and that field of biometrics is burgeoning. So what we need is to be able to say what levels of assurance are necessary, which biometrics are being applied, and to ensure that we can map to them in a consistent manner. And then scale and system. So identity is not binary. It is, and I don't mean that in a social context. I mean that if you are thinking about a system or a business or a clinical or a government or scientific process using an identity, the decisions are made based on a probabilistic curve, a degree of assurance. Right now, there is no standard, for example, a scale of 1 to 10 that says this particular identity is at a level 2. What business or clinical or government process will you connect to a level 2 assurance? Well, no such scale exists. And we need that simple numeric model that maps back to levels of assurances that come from how many biometric attestations are available and other factors. With respect to healthcare, we cannot create digital identities, compartmentalized or otherwise, that in emergency situations, if the patient doesn't have it, can't be recovered. We cannot have digital identities that can be lost and not recovered. It's all fine and good to say, if you lose your private keys, too bad for you. Well, that doesn't work in healthcare. It's unacceptable. So as we think about these infrastructures, a key part of the bioethical posture of all of this is recovery, is reuse, is issues having to do with grievances. So there's a bioethical dimension of this standard that has to do with the preservation, the safety of these identities.
I was just gonna say, somebody else using it. So we're looking at this, I have a small startup, but we're losing it. If you're looking at this, so for example, if you have an identity, but you're a child or an old person and somebody's taking care of you.
Yep, just like consent management generally, in my view, needs to be abstracted up out of EHRs and moved into federated infrastructures. Custodial situations for elder care and child care. We not only need to be able to delegate those authorities, we need to make them granular, specific and time-bound, unique to a certain encounter, specific to a disease state, time-bound, and so on. We need a standard that provides an integration point with national identity programs that are digital in nature. We want that to be a global standard, so that this IEEE standard provides governments globally with a specific mechanism if they choose to link these identities into a national identity program. There is a fixed and structured and evolving mechanism to do that.
Can I ask you something about bioethics? Because ethical issues are widespread all over, cross-sector, but they are not, I would say, ethical guidelines are not the same around the world. So how would you see this coming into the real world space and real world discussion? Would it be by content? Would it be global? How would you be driven this process?
So that is an incredibly germane point, because there is no absolute definition of what is or isn't ethical or bioethical. The only mechanism is to connect it to a cultural identity of some form. So this is very early discussion, but remember earlier I mentioned that compliance modules need to move with jurisdictions, and identities, I believe, should carry an attribution that somehow signals, maybe what religious position, maybe what geographic location, because there will be different standards for, it's completely relative to cultures. Perhaps not completely relative, but at least partially relative to different cultures. So something that tags a bioethical body of knowledge or standards that is endorsed by a particular group is, I think the way we would have to get at that, but it's not a simple issue for sure.
Sorry, can you give us a rough timeline? How far are we?
Well, I will say that my honest answer is we'll never be finished. We'll never be finished. This is something that we will have to continue to evolve indefinitely because, and I know I'm dodging your question, but I'll come back. I'm working my way to it. But the one thing that is a characteristic of all of these technologies and technological advancement in general is that it is accelerating. So we have a pace of change that is already far outstripped the pace of our institutions' ability to react and adapt, and even the human psyche's ability to integrate new information and adapt. So, and it's only getting faster. So I say that we'll never be finished because with the pace of change accelerating, we are going to have to really continue to implement these ideas and keep them moving forward. So that was a little bit of a dodge, but in terms of when I think this standard can be finished, about 18 months, it'll be a first draft. There will be a draft standard released before that, but then people can implement something that conforms with the standard, and parties can certify conformity to a standard, and it's kind of the starting point, not the end.
Yeah.
And the standards themselves also must be evolved. They're not finished either. I think of them like software. It's P1, and we will just like guidelines in medicine that shouldn't really take 10 years to update. Similarly, our standards development processes need to begin to move faster.
Let me get back to that. It's like you will have the first draft of the standard in 18 months, or you will have the first beta of the standard in 18 months.
I think we'll have a completed standard in 18 months. And a draft standard maybe in 12 months. Yeah, that's a guess, not a commitment. That's a guess.
I have another question actually, sorry. When you're looking for this global standard, and this is also something that I'm dealing with, is there in this search for like this global ID or this global standard, an understanding of maybe how to get there, so onboarding? So in these examples or these use cases, you may not be able to get everything, but if you get some of them, if there's a partial list, can those be included? I encourage you to think about that.
Yeah, that tends to come out of the certification bodies. That they will be the ones that stand up assessment models to indicate whether a party has conformed to a standard. So yes, that can certainly be done, but a lot of the value in conformity to a standard is lost if people can claim that they conform in a partial way. So that's a sticky wicket. And another question?
Yeah, how would you see concretely this network of linked non-fungible tokens entering into contact with the framework of biometric attestations? So would you see an experimental group of people, or how would you see this happening? Would it be synthetic data? How could this be happening?
Because actually, how could we run an experiment?
Actually, the idea is that you try to link something that is unique to something that happens in the physical world. And it makes these things really unique, and it can be reconducted really to that person. How do you make this link without any trust anchor, which is the pure decentralization? How would you create this link with this non-existing trust anchor, to which you can say this person is you, and therefore I can run to this or that, or therefore. So how do you see the fully decentralized picture happening and coming to?
You like the really hard questions, and I think it's spot on as a core issue. I'll tell you how I see it happening.
Path to go there, or do you see this happening at the end of the 18 to 24 to 30 months?
Well, in the development of the first version of the standard, we are going to be specifying methods for identifying different biometric tactics. For example, if I call gait analysis one thing and another party calls it something else, and then someone over here is certified to have a valid gait analysis biometric utility. So the semantic framework for defining what the biometrics are. Then the anchor for connecting them cryptographically to a decentralized ID, and the technical specification for doing that in a consistent way. And the final identification of a physical human body would ultimately always be in person. So the final and ultimate identity would have to use those biometrics that have been connected to the digital attestation. But if you want things to run in an automated fashion where the level of assurance is not as high, one step back would be a video feed with facial recognition, for example. And that's why that scale of assurance is so important, because you don't build business and clinical and scientific processes with equal sensitivity. Like if I wanted to change my home address, that might be something that requires a very high level of assurance. If I want to sign up for a mailing list, it probably doesn't. And those are extreme examples. But the idea is that we don't want to embrace or endorse a specific biometric, and we also don't want to assume that they're being used singly. More and more, for higher levels of assurance, you'll have workflows that move a person through a series of biometrics. For example, a facial recognition scan, a handprint, a fingerprint, and a voice print. All of which are mature, scalable technologies today, but have not been integrated very well yet into healthcare or into these infrastructures. Yes?
I think the biometric approach.
Can we take as a good practice to announce your company or title for asking questions, please, so that we can have that in the record.
I'm just a bachelor student here at Frankfurt School.
Thank you for being here.
Biometric approach is very smart in theory, that you link the person to the private key directly, but it's very much hinting at abuse, I think. I mean, let's say we are in a crisis situation, I need somebody with blood type A, and then we can check everybody, and if I'm the authority in that point of time, I can just identify a blood type without a problem, just like doing the face scan, fingerprint scan, iris scan, and I know your blood type. It's
And that's a positive possible benefit, but what if it's wrong? And that's where you get the bioethical implications come in, where you have to also manage your exception cases. You couldn't reliably implement that in medicine without having backups and secondary methods of verification. So it's complicated, but definitely the way that we want to go. But things like birth certificates, vaccination records, blood types, those are being put forward as the foundational things to implement under this identity standard. So the first things we want to link to it are those kinds of foundational records. Yes?
Hi, I'm Jeffrey. I work for Dragon Chains, our document platform. I'm wondering, there are different standards being worked on or finalized. So we also have the W3C community working group.
Yep.
They just released a paper a few days ago. It's also a first draft. So what if they complete their standard and you complete your standard? So we have multiple standards. When we work together, how does it work?
Competition among standards bodies is a very annoying thing for everyone, and every standards body is just like, all you have to do is just use mine, and it works. No, sincerely though, when you at the IEEE, and I believe this is the same for the W3C, At the IEEE, when you start a standard activity, you have to identify what other standards you wish to harmonize with it. And for example, we're doing that with the DID. We're embedding and building upon another standard to extend. So the W3C set of blockchain standards are ones that we're harmonizing with, along with the DID and ISO as well.
So
Yeah. It won't be easy though. I mean, it won't. That's I'm not saying that'll be just no problem. Yes.
Christopher for healthcare. Coming back to the physical link between the natural person and the primary key. It's like there are other concepts too of like password resource like FIDO2. We have a hardware component where you verify. So like what's the concept you are like aiming for? What's the thing you want to do to like make the private key unique to the physical person and also the link to the physical key?
So the DID standard handles the link to a physical key, and key sharding could make it more secure, but it's the cryptographic attestation. So a particular cryptographic utility is identified and is a certified resource, like a public utility that can be called. And that and then connecting that to compartmentalized identities is the high level proposal.
Yeah, but the question is, I'm a physical person. How do I verify myself with the system? How do I have access to my private key? It's like FIDO2 would say like use a hardware key, where you just like have a physical device, you connect to a computer and like a YubiKey, and you verify yourself. Or you do it over biometrics.
Well, in healthcare, I'm suggesting it needs to incorporate biometrics to be interpreted as a legitimate identification. That things that you know and things that you have and things that you are, like the classic cybersecurity identity model isn't enough because it doesn't get to the physical body. But so I would suggest that yes, the biometrics need to be incorporated. That is a suggestion and an assertion. It's we may find that there are reasons why we don't want to do that, but I have a bunch of content left to get through. I'm curious how we're doing on time.
Yeah, so what I would like to propose you is that we go over what you have left and then we take a few questions, maybe 4 or 5 questions at the end, so that we have enough time for everything. Would that be okay with you?
That's perfectly fine. And on the agenda, at the very last session of the day, we have a group discussion about all of these things. So hopefully anything that we don't get to, we can have a very lively and passionate group discussion at the end of the day. All right, so thinking about the bench to bedside cycle, and I'm gonna speed up because I think we're getting close on time, right? Super quick. So a key idea here is that when we're thinking about the innovation cycle from basic research breakthrough to indicated and commercialized drug or intervention or diagnostic, we move through a series of stages. And in this particular case, this family of technologies actually has the ability to positively impact every single step. Right now, it takes 17 to 25 years, roughly, from the time of a breakthrough on the bench in a lab and a mainstream fully adopted intervention or therapeutic or diagnostic. Diagnostics can move more quickly, which is an important point. I'm not going to go through each step in this slide, but just highlighting a couple of things. We have the opportunity to form capital in entirely new ways. What is how R&D in pharma and device gets funded has always been a major challenge area. We have entirely new possibilities for that today. The ability to select sites, and right now pharmaceutical organizations will buy anonymized data sets that inform placements of trials, for example. In this hypothetical future state, we'll be moving away from de-identified data over here and identified data over there. All data will be identified, and the identity can be obfuscated based on the business and clinical and scientific rules and the will and intention of the original data subjects. Very different circumstance when a party that shows up in a disease pool in a market research study can actually be asked whether they're willing to be screened and possibly included in a trial. Post-market surveillance, RegTech, and compliance has the potential to be a completely different world. What we think of today as a digital therapeutic, if it were a Web3 digital therapeutic, it can become a powerful utility for post-market surveillance, pharmacovigilance, real-world evidence, real-world data, affecting everything from a compliance perspective to the commercialization perspective. And then finally, I'm extremely passionate about guidelines and translational medicine. And we have, as we move to blockchain secured data sets that have much higher levels of data integrity than we work with today, our real world data will become ever higher levels of evidence. And this can inform our ability to tweak guidelines and move translational medicine into something that is much more rapid and continuous than exists today. I mean, right now, scientists and clinicians spend a decade or so preparing a guideline, and then the PDF is emailed and published on the website. And then the PowerPoints and CME presentations at conferences all around the world ensue. And then providers go back and may or may not change behavior. That is a completely broken system where we have very little, we go through so much rigor to develop guidelines, and then once the PDF is sent, we do almost nothing to know whether or not those guidelines are working in clinical practice or at a population health level. So incredible paradigm shifting potential for high integrity clinical and population health data. There are a number of consortia that are going on. Importantly, here in the EU, the Innovative Medicines Institute has formed a public-private partnership with 9, and I think it's soon to be 12 global pharmaceutical companies in order to examine the application of blockchain specifically in the EU. I'm proud to be involved with that through our relationship with Pfizer, who is one of the parties that are participating, and they're looking at clinical trials, supply chain, and patient-mediated data exchange scenarios. I'm not going to go over all of these, but we have multiple standards under development. We have deployment of DLT within government context. There's something like 24 different deployments within the United States government, including the very first system to ever be deployed was in the U.S. Department of Health and Human Services. This is a laundry list of my particular point of view on what barriers to adoption we actually have and what it's going to take for us to move through these cycles. I'm not going to go into all of them in detail, but many of them are universal. They're not specific to healthcare, but there are healthcare specific angles on them. Quickly, this is a deliberately messy, disorganized laundry list of use cases in our industry. And I made it this way specifically to frame the question, how in the world would you transform an industry so complex? What would you do first? How could you create any sense of order in such a complex transformation across use cases, and let alone all of the other technologies that are also on their development curve? So I proposed a framework that I call the PHI for Protected Health Information Readiness Framework that juxtaposes an x-axis with time and the involvement of health data in a use case, and a y-axis of population health impact. I propose 3 macro stages for transformation of our industry. We are presently in stage 1, well into stage 1, and you'll note everything on this left side are the projects that are getting traction today. What I observed is that there was a pattern as to why certain things were getting traction and other things were not. And it was simply the degree to which health data was actually used in the use case. So think about supply chain, no health data. Provider directory, public information, no health data. Many aspects of the revenue cycle, credentialing, these are incrementally beneficial use cases, but they don't exactly get to the holy grails of healthcare. In order to get to stage 3, we have to have at least achieved incremental progress toward the identity challenges that we have. And that's where we will be able to use this technology to achieve precision medicine objectives, care coordination across organizational boundaries, clinical integration across specialties that treat complex chronic diseases, and get to the vision I was describing earlier about ultra-secure, incentivized, next-gen digital therapeutics. But what do we do in the meantime? Big, giant question mark. Are we just going to wait for some anonymous, unknown, unaccountable party to somehow fix all of our problems? It's not going to work. So we have to have some method to bridge these worlds. And I propose that all forms of IRB overseeing clinical research is the appropriate bridge through which we can transform as an industry. So essentially I'm saying anything in stage 3 that we cannot do today in heavily regulated health economies, we could do right now if we organized it under a well-designed study and didn't try to deploy or implement straight into mainstream medicine. So we could be looking at patient-centered, health economic, clinical, and population health outcomes. This could include things like quality improvement programs, registries. We can ethically and appropriately go into these more strategic, more potentially revolutionary kinds of implementations now by using this approach. And most people in the room here are healthcare and life sciences folks, so you know why this is. A study abstracts patients into participants, providers into investigators. It has its own flow of capital and payments. It is, by definition, it has to run on a separate technology infrastructure that is overseen. It's got its own regulatory function. It is a walled garden that exists within mainstream medicine, but is abstracted away in a way that is contained and measurable. So strategically, I think this is a very important thing to get our heads around, that we have a mechanism, and it is appropriate. It is an appropriate and ethical mechanism to advance this. And in this, everything in stage 2, there are 2 contexts of value creation. The core research questions that are going to be asked under this scenario, we have a reproducibility and replicability crisis. We have major problems with research data, and I think everyone in this field is very aware. By using a blockchain-based infrastructure in the core administration of a clinical trial, and I mean a blockchain-based CTMS or clinical trials management system, or a blockchain backbone against an existing clinical trials management system, we can radically change immediately the data integrity posture of all of that. But that's only one of the contexts for value creation. The other thing that we need to do is include as secondary or tertiary endpoints in study design the impact of this technology on the research subjects, on the conduct of the research itself, and so forth. So we have two models where we would be creating value by using that strategy. And then quickly, there are 6 requirements that underpin all of the more mature stage 3 use cases. Patient-mediated data exchange, aggregation, curation, and monetization, which, by the way, is the subject of the panel in a little while, is ultimately everything will come down to that. We've talked about revolutions in identity. We have to have a user experience in Web3 dApps, decentralized applications, that looks and feels like the experience that consumers are accustomed to today. And I've already talked to you about this standard. Anybody who would like to be part of that, please reach out to me. I proposed these discussion questions for later in the day for our group discussion, but validating the sustainability and effectiveness of different governance models, security models, ownership structures, focused on capital, risk, technology, data, and intellectual property. That's a juicy topic right there. So I thought I'd leave it with you to inform our discussion later today. And that is all. Thank you very much.
Thank you very much. Other questions? We have some time for questions. I know there were.
Again, Marguerite from MedPayRx. We actually are going forward. MedPayRx was a thesis project, EMBA thesis project here at Frankfurt School. I graduated in 2017. Our focus is medical cannabis, as well as prescriptions and everything that you gain by prescription in your own system. And we've approached the city of Cologne to do a first of its kind in Europe, city medical cannabis trial across the city, looking at our technology. Because our point is that while medical cannabis may be, I guess, still a little stigmatized, that's actually hitting a new kind of medicine that is going for people who are really sick and hits all of these issues within our own. So I'd love to follow up on you, but thank you, this was awesome.
Congratulations on your progress.
Well, we hope to work with a coalition of folks, that's why we're here.
All right. Thank you. Other questions? Yes, please.
I like the graph you were showing in terms of the y and the x-axis. I have a question. When you talk about scale,
One moment. Sorry, I'm not hearing you completely.
so I mean, if you want to go back to the slide where you had the graph. Yes, maybe this one. I think it's a nice one, and it resonates at least a little bit with what we are doing here at Novartis. But what about scale? Which is the definition of scale? Is it only the patients and the patient population the scale? Is it the technology's readiness the scale? I mean, where is that scale? I'm just trying to understand that.
So I think, where does the scale of the technology come in to the
Either
picture?
me or the technology both need to be at a scale level to where it's basically married. And
Yeah.
where is that?
Well, so part of my supposition that in stage 2 we need to do things under studies, it by definition descales the scope and magnitude of the systems that would be necessary to do that. For example, infrastructures that could support maybe a 100,000 patient series in a quality improvement program is very different than 30 million patients, for example, being supported in a public health scenario. So the activities that are going on to scale public networks and also we have a vision for public networks bridged to what we call side chains, which are private blockchain networks that tether to a public blockchain network, such as the Ethereum mainnet. That is a technology that is almost there. I mean, it is right at the cusp. And that's the mechanism by which I see most of the technical scaling coming in healthcare. The use of a public blockchain would be specific to discoverability, so that you could discover trading partners, individuals, consumers, for example. But business and clinical scientific processes wouldn't run on a public blockchain itself. So the activities to scale public blockchains are incredibly important, but my particular point of view is that all the volume and the workload is going to be off on side chains.
Mm-hmm.
And that's not too far away. I hope that answers your question.
The framework which you're working on, is it somehow technologically agnostic, or are you biased towards the Ethereum type of blockchain?
Did you say the identity framework
The
or the
framework
overall framework?
overall.
So my belief is that this overall framework is itself technologically agnostic. I focus extensively on the Ethereum ecosystem, but in healthcare and life sciences, that has to mean and include interoperability. It means we need interoperability of of decentralized crypto assets. We need interoperability of smart contracts. We need portable identities. So you can't build everywhere at once. People have to make a choice and build somewhere. And I happen to be a big believer in the Ethereum ecosystem and its value, but that does not mean that we can create lock-in at the platform level, especially not in our industry. So being able to demonstrate interoperability at scale across blockchain networks is a personal priority of mine, but you have to build a system and implement a system and then have another system over here that is implemented to show, so it's still a little bit down the timeline, but it's a top priority.
So, sorry,
We've got a lot of questions. Wow, this is so exciting.
you mentioned interoperability. I run blockchain for DHL. I'm running the COE for DHL. Very happy to hear that, because when we talk about logistics and then clinical trials and different or proofs of activities happening, right, during the whole life cycle. My question for you is it the Pegasus, the new Pegasus launch that you're looking at for interoperability, or?
So ConsenSys, so what you're referring to for the rest of the audience, ConsenSys, we built an Ethereum client called Pantheon, and we made a recent decision to contribute that already open source code base into the Linux Foundation's Hyperledger project.
Right.
And the Linux Foundation accepted our contribution. So now there is a public blockchain compatible Ethereum client that is also equally effective at running private blockchain networks inside the Hyperledger framework. Hyperledger is about 15 different code bases with a common set of governance organized by the Linux Foundation. And the key advantage of our moving our Pantheon client, which has been renamed Bezu, by the way, Hyperledger Bezu, which means a base or a foundation in Japanese. A key advantage is that the technical communities at an engineering level that are working on those, I think we were number 16 under the Hyperledger family, something like that. There are deliberate and well-organized mechanisms for achieving interoperability across the Hyperledger portfolio. And it's a high priority focused on enterprise needs for blockchain. And our perspective is that enterprise needs include the use of public blockchains, but are not limited to in any way. Because there's if you only have a permissioned blockchain, the only way for a person or a business party to join it would be to send an email or send a fax or make a phone call. That obviously isn't tenable. If we want discoverability of individual humans and economic actors around the world, only a public blockchain can fulfill that. But it doesn't mean that that's where you need all the transaction processing to happen.
Great.
Did that answer your question? Thank you.
So, Pierre Maroon from the Open Commission. I would like to come back to one of your blogs at the beginning of your presentation, which is about decentralized AI. And I would like to understand what is the role of blockchain for linking those different data sets and maybe facilitate decentralized AI. What do you have in mind exactly?
You know, I would be happy to stumble through that answer. But we have a talk coming from Dr. Jonathan Pompak, that is his specific area of specialization, and we happen to be colleagues. So I will answer only extremely in brief, but if you think about a machine learning algorithm that instead of running on a centralized data lake is running at the edge, for example, on your cell phone, or on a particular data store behind a corporate firewall or what have you. So instead of centralizing data and then training information on that data, you're getting an algorithm that's learning, and then you're deploying the algorithm all over the place at the edge so that it can learn and return inferences. So the key question of why blockchain in that scenario? Well, this invention of federated learning, which is what that's called, is not new. It's 10 years old? As it for roughly.
It's even been like popularized by Google like about 3-4 years ago. So the concept of federated computing have been there, but applied at this large scale for machine learning, it's very new.
So invented about a decade ago, getting some scale 3 or 4 years ago, but why not massive scale? Why hasn't it taken off? And I would argue that because it needs to be integrated with a blockchain infrastructure. Because if you wish to track the deployment of an algorithm somewhere, who gave you permission to run it or to deploy it? And then you learn something and you need to send an inference back. How do you know which party actually sent it? How do you know that it wasn't tampered with? How is it verified? So everything from access control to recognition of value creation, all of those things don't exist in the current state because blockchain isn't paired with it. So we see this federated learning that is blockchain facilitated as being the business compliance policy and ethical enabling technology for federated learning. I hope that, I'll see how Jonathan can critique me during his talk to come. Thank you.
Maybe one last question. We have many other interesting topics to cover today, so
You select, please.
I think the third behind race design before.
Hi, I'm Simon. I'm a smart contract developer working for Mikobo here in Frankfurt. I was wondering, since you said you work at ConsenSys, obviously you have some sort of preference for Ethereum. I like that you want to do practical implementations while you are developing the standard. I just want to ask, what are the projects like NIM, 3box, what are the things that you want? Are there like projects you can work with, or who do you like? Who do you think is the furthest along or like congruent to your ideas so far? Like just a quick picture of what you think of the space right now, because there are people working on these things already, right? So
Absolutely, and ConsenSys is among the parties working on these things, but we also hope to support the community broadly. So we have kind of a dual role in that way. Falling short of product endorsements, which would not be an appropriate use of my stage time, I will say that ConsenSys has 8 different enterprise products that it has developed over time that we feel have applicability to healthcare. We're working with those. And we have an extensive partner ecosystem where both, whether it's on the same platform or on the Ethereum platform, if we see an opportunity to do what's right for patients in healthcare, we want to be a part of it. So that was a very vague answer, but I'm sure you understand.
come back to it.
Thank you. Thank you, everyone.